Okay, let's take a look at a couple more examples, just like what you saw in the last video, but this time less theory and more just direct application in the calculator. Number 1, more time on the internet. The General Social Survey pulled a sample of 209 people aged 18 to 30 in the year 2000, asking them how many hours per week they spent on the internet. The sample mean was 6.75, and standard deviation from that group was 7.71. A second sample of 541 people aged 18 to 30 was taken in 2006. For this sample, the mean was 7.34 with a standard deviation of 10.93. Assume these are simple random samples from populations of people aged 18 to 30. Can you conclude that the mean number of hours per week spent on the internet increased between 2000 and 2006? Use the alpha equals 0.05 level. Okay, so at this point, you're looking at this, you're recognizing that it is a hypothesis test because of the significance level. As soon as you see that, that's your clue that you're doing a hypothesis test. Hopefully you also recognize that this is 2 samples involved here. So this is a 2-sample hypothesis test. And the other observation that I want you to make is that the people that were polled in 2000 are a completely different group of people than those polled in 2006. And so we do have 2 independent samples here. Okay, so what are the appropriate null and alternate hypotheses? Well, before you even make those hypotheses, in a lot of these problems, I suggest writing down what is your first group and what is your second group. And that way, you'll set up the hypotheses correctly, but you'll also put things into the calculator correctly. So group 1, I'm going to say that that is the 2000 group. And group 2 is the 2006 group. Okay, and so given that, our null hypothesis is that the mean number of hours per week spent on the internet there's no change between 2000 and 2006. And so that the mean from group 1 is going to equal the mean from group 2. But as you can see from the last statement here, the last line in the example, it says, can you conclude that the mean number of hours per week spent on the internet increased? And so that researching hypothesis is that the mean time did go up. And so you would say that mean 1, now a lot of people would say, oh, it says increased, and so I need to say greater than. But in this case, if 2000 is our first group, then mean 1 would actually be less than mean 2, right? Your alternate hypothesis is that the average amount of time spent in 2006 is greater. That's why this is opening up to mean 2, and it's set up like this. Now, can you see that if you would have swapped this, where group 1 was 2006 and group 2 was 2000, then in that case, you would have had this mean 1 being greater than mean 2. And so you've got to be consistent throughout your entire problem. And that's why I always suggest noting what your groups are before you even create your hypotheses. Okay, so we have our groups, we have our hypotheses. I think that at this point, we can recognize that we are going to use 2SAMPTTEST. So let's just go into the calculator, back to 2SAMPTTEST, and see what we get. So we press stat, test, 2SAMPTTEST is number 4. And my first group was 2000. And so when I enter this into the calculator, I'm going to go with the 2000 data at first. And so that was what I underlined in the problem. And so the sample mean was 6.75. The sample standard deviation, 7.71. The sample size was 209. And now my second group is the 2006 group. So I'm going to use the circled data from the problem. And so in that one, the sample mean was 7.34. The sample standard deviation is 10.93. And the sample size of that group was 541. Make sure to select the correct alternate hypothesis. And here I know to select this one. I think the harder thing is actually setting up the alternate hypothesis correctly based upon how you label the groups, like I was just talking about. So we're going to just scroll down and hit the calculate button, and we will get our p-value, and we see we get a p-value of 0.2034. And so if you get a p-value of 0.2034, we can see that that p-value is nowhere near lower than our alpha cutoff. Since our p-value is greater than alpha, then we would say we fail to reject the null. And so based upon the data, it is inconclusive. It is inconclusive whether the average amount of hours per week spent on the internet increased between 2000 and 2006. So I'm not going to write all that out, but I'll just mention it one more time. It is inconclusive that the mean number of hours per week spent on the internet increased between 2000 and 2006. Our data are just not strong enough. Okay, let's go on to example 2. It says, are you smarter than your older brother? In a study of birth order and intelligence, IQ tests were given to 18 and 19-year-old men to estimate the size of the difference, if any, between the mean IQs of firstborn sons and secondborn sons. The following data for 10 firstborn sons and 10 secondborn sons are consistent with the means and standard deviations reported in the article. It is reasonable to assume that the samples come from populations that are approximately normal. That's good because we have small sample sizes. Can you conclude that there is a difference in mean IQ between firstborn and secondborn sons? Use the alpha equals 0.01 level. So again, we're doing a hypothesis test. There are 2 samples involved, IQs of firstborn and then IQs of secondborn. And those samples we are going to say are independent. We do not necessarily know that this number is the firstborn from one family and this number is the secondborn from that same family. There is no pairing actually happening here, although I could see how some of you might think that. But in this case, we're going to assume that it's independent. So ultimately, we will end up using 2SAMPTTEST yet again. But before you just jump to the test, do the other things that I've mentioned, including let's label group 1 and group 2. And then the other thing is, let's set up our hypotheses. So the null hypothesis is that there's no change in the mean IQ between firstborn and secondborn. So that would be the mean of group 1, the population mean IQ in group 1, the population mean of all firstborn sons is equal to the population mean of all secondborn sons. But the researcher is thinking, no, we're considering the idea that there is a difference in the mean IQ. And the fact that there's a difference, and they're not necessarily saying that one is going to be greater than the other, tells us that the alternate is mu1 is not equal to mu2. So let's go to 2SAMPTTEST. That's stat test number 4. And you can see that we're going to have to go to data in this case because we don't have the summary stats. So I'm going to go to data, and then I'm going to have to make sure that I enter my group 1 into list 1 and my group 2 into list 2. And then we'll come back to this menu in just a second. So I'm going to press stat edit. And if you have anything in your list, we know to clear the list, you press clear enter. And so my firstborn 104, 89, 82, 114, 102, 107, 96, 89, 129, and 103. And then my group 2 is going into L2. So that's 103, 103 again, 103 again, 92, 91, 90, 113, 114, 102, and 113. Let's go back to Stat, Test. Remember, we're in 2SAMPTTEST, and we've selected Data. We put our Group 1 in List 1. We put our Group 2 in List 2. Leave frequencies of both of these on 1. And let's select the correct alternate hypothesis, which in this case is going to be the first one, is not equal to. And then let's go calculate. And this time we get a p-value that's really large. In fact, our p-value is 0.8646. And typically, remember, a researcher is hoping for a small p-value because then that allows them to reject the null and accept the researching theory. But in this case, we've got a p-value that is definitely much bigger than 0.01. And since the p-value is greater than that alpha cutoff, again, we fail to reject the null. And if you fail to reject the null, then that means it is inconclusive once again whether or not there is a difference in mean IQ between firstborn and secondborn sons. Okay, so hopefully this helps. In the next video, what we're going to do is talk about hypothesis testing for the difference of proportions. So check that one out.